I think I got better seat.
What do you think of what?
Those are very cool. Did you get those for Christmas?
Good. What do you think, Mr. Johnson?
Are they crabs or lobsters? Nice.
Let's go. I'm the closest to Mr. Townsend.
Wait a minute. Oh, you are, aren't you?
I try not to put anybody in this seat because I feel like it's too close, but my bigger classes, someone has to sit there, so.
Okay.
I'm 2-3 inches closer. Sorry, bro.
No.
Where are you? I've been moved to the front.
Yeah, you needed that. Y'all have been separated. You guys were separated.
You can bring them up. Thank you. Hey, this says 19.
But at the end, there's some actual calculus. Thank you.
Yeah, if y'all forgot the handout and the textbook sign, please go get that stuff.
I did.
Been a while. You'll also need a calculator today, so please come borrow one if you need one.
Hello, Senor Townsend.
Oh.
What?
Dude, you got them?
Bro,
I literally just got those for Jen. Yeah, like this is like a joke gift.
what the heck?
That's hilarious. I'm not that.
He's calling your shoes jokes.
I like them.
Yeah. For the stuff.
They said the thrift store was where the heat was at.
He found the heat.
Oh, man.
I think he's just taking all the heat.
I heard today. I'm sorry.
Yeah, I hope so. How much money would someone have to How much money would someone have to pay to drink the Woodford tub? That stuff looks disgusting.
Jeez.
I
I've
just
seen
realized
worse,
today that
though.
you're Olivia Carter's sister, her brother.
What?
Sister.
What?
I just realized that you're Olivia Parker's brother.
Wait, who is that?
Oh, she's in our grade.
Okay.
That's me. Boy, y'all are
Wait, you're in the
juniors.
11th, right? Junior? Yeah. Okay.
Nerds, old people.
What?
My sister's a nerd, though, so. I ain't like her.
Very much so. He just built
Wow. Wow. I swear, I would.
Sorry for calling you her sister.
It is fine. I swear, out of the 3 siblings, between my oldest sister, her, and me, she was like the biggest nerd. She was like the biggest like overall.
Okay,
school.
one more time, you guys do need a book, calculator, and the handout up front. So I know it's been a while. If you forgot that, please go get it. Hope you guys all had a nice, restful break. It felt like it was a little bit longer this year for some reason.
I think it was.
Yeah.
Get
It's usually,
short.
We got back the 6th last year, while also getting out like the 23rd.
Really?
so
Yeah,
it's
that
still
is-
2 weeks, right?
Yeah, but like this was like. It was more.
It was
We
like
got
2 weeks
16.
plus a couple days.
Yeah. Thank God.
All right, so first off, we need to discuss just kind of an overview of the semester. Our second semester is quite a bit different than our first semester, so I'd like to kind of give you a heads up on that. So, of course, first semester is almost entirely about trigonometry. Day one, we started with radians, quickly moved into unit circle. Of course, we did some other stuff, but it was a lot of unit circle, a lot of SOHCAHTOA stuff, lots and lots and lots of trig. Second semester has just a touch of trig. Usually the unit circle is about the only thing that you have to remember about trig in second semester. We do quite a bit more algebra. So in fact, the first 3 days here, we're going to do something called law of sines and law of cosines, and I'll get into why we do that. So we don't spend much time there. Then we'll spend a couple weeks on limits, which is actually the very first thing that you would do in a calculus course, whether that's Cal AB next year or even college calculus. So that way if you get an idea of what type of stuff calculus actually starts with, and then if you're doing that next year, you're a little familiar with it. It makes it a little bit easier of a transition. We'll spend a few weeks with that, and then the rest of the year is mostly algebra review. So that means sometimes we spend more time than you've done in the past. Like we'll probably spend 3 to 4 weeks on exponentials and logarithms, even though you saw those in Algebra 2. Regardless if you go on the calculus or if you're doing college algebra, logarithms are super important, and the amount of them that you learned in Algebra 2 is just not sufficient. So we spend quite a bit of time on that so that you can get a very good grasp on it. Spend probably like 2 weeks on rational functions, which will be 99% the same thing you saw in Algebra 2. We'll probably spend a couple days on polynomial functions, which will be 99% the same thing you saw in Algebra 2. So for most people, they think second semester is easier, but it really just kind of depends on how well you learn that algebra stuff and how much of it you remember. Generally, if you remember the majority of it, then it's quite a bit easier than the trig stuff. But of course, not everyone's grade is higher second semester, but I can tell you from like the 10 years I've been teaching pre-cal, that like the average grade in gradebook is usually about 5% higher second semester. So just as a quick rule of thumb, if you put in about the same amount of effort, you should expect about 5% higher. Of course, if you don't put in the same amount of effort, then it's not guaranteed, of course. Our binders, so you can see with the handout that you guys picked up this morning, number 58, I do continue on with the numbering, but you do not have to carry around first semester stuff for me. You're welcome to if you want to. I would suggest you buy a new binder, or just take out your first semester stuff when you're at home and put it away somewhere safe, and then at the end of the year you can combine them. But I'm not going to ask to see number 57 or lower. But if you want to have that stuff, you can. But we're not going to restart the numbering. Okay, but for the first couple days here, before we get into limits and then algebra review, we like to do a couple days of what's called law of sines and law of cosines, which sounds like a lot of trig because of sine and cosine, but you really don't need much background information. In fact, this used to be taught at geometry level. I guess if you had a teacher that pushed a really hard like honors level geometry course, you may have seen it, but generally it doesn't get to it very much. So I'm going to show you what that stuff is and why it's good for you to know it. We'll practice it a little bit in a bookwork today, and then we'll practice it in a practice assessment on Friday, and then we'll have a quick 20-30 point quiz and then move on from it. And that wouldn't be till Monday though. Okay, so the reason why we like, well, we don't really do law of sines, law of cosines for us. In fact, this doesn't get used at all in calculus. It's not at all helpful for college algebra. It would be helpful if you ever take college trig. You would probably have a test on this in that course. But the reason why we give you a couple days on this is because this is one of the couple topics that we do in pre-cal that is very, very often on the ACT. It's becoming one of those that it's on the ACT like every other time. So we want to make sure that you can get those questions correct. So first off, to compare and contrast here, last semester we did a lot of finding side lengths and angles, like with SOHCAHTOA and Pythagorean theorem, but the big takeaway was that they always had to be right triangles. Whereas law of sines and law of cosines can help us solve oblique triangles. Oblique just means it doesn't have a right angle. So any triangle, right triangle or not, law of sines and law of cosines will work. So here is the law of sines formula. Caroline, you with us? You with us? Are you following along? Okay. These are the formulas for law of sines. And we don't even make you memorize these formulas. We'll actually put them on the quiz for you. Again, our focus here is you to be familiar with it enough that you can get it right on the ACT. It doesn't really have any application for us outside of that, so that's why we don't make this any harder than it needs to be. But I tend to, even though these are really the same formula, I tend to write it like this if I'm finding a side length, because the side lengths are already in the numerator. Remember, ABC, lowercase, is for side lengths. And then I tend to write it like this if I'm trying to find an angle measure. But they're the exact same formula. It's just they took the reciprocal of one side, so then they took the reciprocal of all sides. So you do not need to memorize the formula for us. But what we will ask is, when can you use law of sines? So the when is anytime you have two angles and one side length. So in math, sometimes we abbreviate that. That could be angle, angle, side, or angle, side, angle. Any two angles and a side length, law of sines will work out great. You basically just plug the numbers in where they're supposed to go, solve, throw it in your calculator, and you're done. And sometimes when you have two side lengths and one angle measure opposite one of the known side lengths. So, you know, two side lengths and the angle opposite one of those sides, known as side-side angle. Okay, so you guys have kind of heard of that before, right? These type of things from geometry. All right, so there are certain ones that prove that triangles are congruent, which is just a nice way of saying that this is a unique triangle. So these two prove triangle congruence. This was not one that you probably used much, if at all, in geometry, because it doesn't always work. It sometimes works. This is what's referred to as the ambiguous case. And if you do ever take a college trig course, when you do law of sines, law of cosines, they will make you know and understand the ambiguous case. And in the past, up until 2 years ago, we always made students learn the ambiguous case. And it's not that it's hard, but it's kind of wordy. There's like a bunch of different cases. You have to check for this, and if this isn't true, you've got to check for this, or this, or this. And I don't know, you got to do like 20 of them before it kind of really, or 40 of them before it really kind of clicks what you're doing and why you're doing it. So for us, we will not require you to know and understand the ambiguous case. But if you notice on our agenda here, there is this video that you're welcome to watch that explains the ambiguous case. And I think our plan is we'll put like one question on this quiz that'll be a bonus question. So if you care enough to get the bonus question that you're willing to go and learn ambiguous case on your own, then go for it. But like I've been saying, that doesn't show up on the ACT, so that's the only reason we're doing this. So it just doesn't make sense for us to spend an extra day to go around in circles doing that. So what the reason why it gets kind of complicated is depending on how big these side lengths are and how big this angle is, you can actually get no triangles with those possible lengths, one triangle like these always are, or you could even get two possible triangles. So you have to put a bunch of time in figuring out which one is which. But that will not be required. Okay, so I've got two examples written up where someone found a side length and found an angle using law of sines. So notice these two look like the law of sines formula with some numbers plugged into them. They did sine of 48 over 10. Notice how those are opposite each other. And sine of 55 over x, those are opposite each other. You need that to happen. And then the solving looks like they cross multiplied and then undid multiplication with division, and then go from here to here. They just use their calculator. So as long as you plug the numbers in the right spot, usually pretty simple solving, and then the calculator is going to do the hard arithmetic anyway. Finding an angle is basically the same thing. You need the sine of x over 12, and then the sine of 42 over 22. You got to match up stuff opposite each other. And then you go through and you undo divide 12 by multiplying by 12. And then this is probably where you need to put highlight or put a little more care into. When you get this, that's not your angle. That's what the sine of your angle is. Now remember, sine can only be from -1 to 1. You don't have to know why anymore. That was last semester stuff. But to get the angle out of that, you need to do inverse sine of that before you get your actual angle. So if you want a side, you're going to be using sine and cosine, law of sines or law of cosines. If you want an angle, you're going to need to finish with inverse sine or inverse cosine. All right, so that gives you the gist of that. Usually after you do just a couple of those, you can see that this pretty nice formula. It doesn't have to be a right triangle. You plug in 3 lengths, you solve for a different one, and you have more information about your triangle. Okay, moving on to the other one, which is law of cosines. So law of cosines formula can be written 6 different ways. And again, I will provide those for you, so don't feel like you need to memorize them. But I like to maybe use these 3 if I'm trying to find a side length. Over here, these are good if you're trying to find the side length. So like if you were trying to find side A, maybe use the top one, side B, the middle one, or side C, the bottom one. And these 3 over here are set up and solved in a way that they're just about ready to find an angle measure. Now, same as laws, I don't know how you could not learn the law of sines after you write it down a couple times. It's pretty hard to unlearn, but law of cosines, you also don't have to memorize these, but you do need to know when you can use them. Now for these, I feel like this is a little bit easier because if you forget, you can kind of look at what you have. If I'm trying to solve for side A, B, or C, it looks like I need the other 2 side lengths. And if I'm trying to find side A, I need angle A. If I need side B, I need angle B. If I need side C, I need angle C. So we need the angle inside of those 2 side lengths, which in math we call included angle. The shortcut for that would be called side angle side. You know, 2 side lengths and the angle that's stuck between those 2 side lengths. Whereas if I was trying to find an angle measure, if I just look at the formula, whether I'm trying to solve for A, B, or C, it looks like I need to have all 3 side lengths. So if you have side angle side, you can use law of cosines to find another side, or if you have side side side, you can use law of cosines to find an angle. But we will ask you when to use law of sines and when to use law of cosines. So again, memorize that if you need to. Now again, even though you don't have to memorize these formulas, I kind of like to highlight this one down here. What do you notice about this one?
Hey, Pythagorean theorem plus that thing.
Right, it's almost a Pythagorean theorem. A squared plus B squared equals C squared. And Pythagorean theorem only works when you have what kind of triangle?
Right.
Right. Correct. It is a right. When you have a right triangle, it's just A squared plus B squared equals C squared. Well, if you tack on this part, minus 2AB cosine C, this works for all triangles. So, I don't know, this has always been my thing, but I don't understand why in geometry you don't just learn this and ditch Pythagorean theorem. Because what happens if this angle, what if it is a right triangle? What is the If I plug in 90 degrees for angle C, what is the cosine of 90 degrees?
One.
Excuse.
Go to 90
Zero.
0. So it makes all of this go away. So when it's a right angle, none of that matters, and that's why it leaves behind Pythagorean theorem. But I don't know. I just feel like if it's a right angle and all this goes to 0, great. And if it's not a right angle,
The guy
it'll
was
work.
jealous. What can you say?
Yeah, I don't know.
He was just
I'm
jealous.
sure there was some
Smarter.
politics in the past about that. Okay, so quickly, here's a couple of examples already typed out so you can see how it works out. Looks like this person realized that they had side angle side, so they knew they could use law of cosines, so they wrote the formula down. They assigned letters to these things. One side is A, one side is B, one side is C. One angle is angle C. Remember that side C has to be opposite angle C. Looks like they plugged in all that information into step 2. And to be honest with you, I don't know why they even bothered with the next 3 steps. If this was me, you're going to need a calculator anyway. So just go from x squared equals to x equals by doing the square root. And then just carefully put it in your calculator. And you're going to get that as an answer. It's not a hard formula to use. Honestly, a lot of what you need out of the practice is just making sure that you're putting it in the calculator correctly. But that's law of cosine. Side angle side, pick off a formula, plug in what you've got, solve for another side length. And then on the right, we've got where they used it to find a couple angles. So here's law of cosines. They picked the side A, B, and C. Plugged in A, B, and C where the formula said. So notice some of these numbers are slightly in different spots. That gave an answer between -1 and 1 because that's as big or as small as cosine could be. Because you're trying to find an angle though, you need to do inverse cosine of that to get your angle answer. So same thing that I asked you to highlight about law of sines. To get your angle, you need inverse cosine of the ratio. Okay with that? So again, I know you need to practice a couple of them before you are sure that you've got the hang of it, but anything that jumps out at you about law of sines or law of cosines immediately. Okay, the other 2 things that we squeeze into this that fit into, yeah.
Sorry. So you're supposed to just like, if you want to skip those things, you just square root it all?
Down here?
Uh-huh.
Well, it's what all of this is equal to x squared. So if you want to know what x is, you're just going to do the square root of all that. For some reason, again, I didn't type this up. I just took this off the internet. But for some reason, they figured out this was 100 and this was 81, and then they multiplied these together. Like I don't know why they made so many steps out of it. If you're going to use a calculator in the end, you might as well just let your calculator do it several steps past. That was all I was trying to say.
Internet.
Okay, so the other 2 things that we want you to learn in this that go along with it is 2 new area formulas. So the one that you know right now is 1/2 base times height. And by the way, I have seen this on the ACT as well. Very, very easy question if you're familiar with these formulas. But if you know side angle side, there are 3 other formulas that also work. Because, you know, I know in a geometry class, you know, your teacher says the base is this and the height is this, what is the area? And you just multiply them and divide by 2 and you're done. But you don't always know the height of something. So I'm going to show you in depth on one of these so you have an idea of where it comes from. Doesn't really matter. So you can see where it comes from, and then I'll just show you the pattern for the other 2. But again, at the end of the day, you don't have to memorize these either. But it would, I guess it would help you recognize it a little bit on the ACT, so I'll leave that up to you. So when I draw this triangle, which one of these sides would you think would be the base?
Definitely BC.
Okay, what's another name for BC?
BC with a
Side
line.
A.
Okay, or side A, right?
Oh, yeah. You're right.
Okay, so the base could be A, but instead of calling the height H, which sometimes we're not just flat out told here's what the height is, you guys have enough trig background now that you could go about figuring out the height. The height is the distance from the opposite vertex perpendicular to the base. Now again, you don't have to do this normally. I'm just showing you in depth on one of them. If I draw in the height here and I look from this angle, I could say the sine of angle B is equal to opposite over his hypotenuse. I'm just looking at this right triangle, which would be side C. So another way to say, when the base is A, another way to say the height would be to say C times the sine of B. Again, it's no different than just the SOHCAHTOA equation, but if you know the formula, you don't have to go through and try to manually figure out the height. You can just plug in the numbers as the formula says. Now the thing is, A is not necessarily the base. I know you want to pick A to be the base because it's on the bottom, but I could certainly turn this shape and B could be the base, or even C could be the base. Any side can be the base. But there's some pattern here. If B is the base, then we might have a height of C times the sine of A. Again, I'm not drawing it all out, but I'm just trying to show you some pattern here. So if I've got 1/2 AC sine of B, 1/2 BC sine of A, what do you think the last one should be?
Sine of C.
C,
C sine C.
B sine
A sine
of
of B.
A. Or no.
Hold on, I may have.
What do you think, Ray? Silent now,
Okay, well what two sides have I've used AC, BC, so what sides have I not used?
C. CC. CC's B.
Okay, well we don't want two of the same.
Oh, okay, so B of C. B sine C.
C sine of
A sine C. C sine A.
B sine
No, we already have that.
A. B sine of
Guys,
C.
rotate it.
No, we don't need to go through that. I may have just written this one down.
That's what I'm saying.
AC, BC, we don't have AB. We have AC, BC, but we haven't used sides A and B.
We said that.
Okay, well you also said 20 other things. Okay, and then the angle that would be in between side A and B would be angle C. So there's a pattern here, and that's why I don't think it's that hard to know. But again, we'll provide the formulas for you. But if you have side, angle, side, these three are a little bit more efficient to find the area than to sketch a triangle, draw the three lengths, and then you go through and try to find the height with the SOHCAHTOA equation. But essentially that's just what's being done for you. All right, and then finally, the one, I like this one a lot, and I also don't know why they don't show this one to you in geometry because it's very easy to use and very useful. Anytime you know all three sides of a triangle, all three lengths, there's a thing called Heron's formula, and he says that the area of any triangle is going to come out to be the square root of S times S minus one of the lengths times S minus another length times S minus the last possible length. And then your question should be, well, what is S? So S is when you add up the three lengths and divide by a number. And what number would you think it's going to be?
Pi. No, that's circles.
Okay, and why do you think it might be 3?
There's three sides.
Okay, so put a 3, but put an X through it. This is not an average. Again, I will provide the formula for you, but I can tell you, as much as I try to emphasize it, and even putting the formula on the actual quiz for students in the past, sometimes still people put 3 there. It's actually a 2. This S stands for semi-perimeter. Just like a semicircle is half of a circle, semi-perimeter is half the perimeter. So it's not an average, it's half of what the perimeter would be.
That's so cool.
And that's it. So any three side lengths that actually make a triangle, solve for S, plug it into all of this, and you know the area. Very useful and not at all hard to use, especially if you have a calculator. That's why I don't know why they don't show in geometry, but. Okay, so finish copying that down, please, and then you will need a blank piece of paper. If you go ahead and copy the assignment down, and I'd like to give you time to try 5 to see what, if anything, is holding you back before we go over that one as a group on the board. So there's a couple questions on page 406. So a couple using the law of sines, a couple using that first area formula, and then a couple word problems, and then the same idea on page 413, but with law of cosines.
Do you know what my New Year's resolution is, Mr. Johnson?
To do all your homework on time.
It is actually.
I know.
I'm not kidding with you. Like, it's crazy that great minds think alike.
Yep.
I mean, one of our brains might be greater, but I won't disclose whose. So. I'm kidding. Yours is.
I'm sure you will all be much smarter when you're my age. But right now, I've got too much life experience.
It's true. I'm only 16. You're like 10 years older than me.
That's about right. Okay, so again, I'd like to give you time to also try the very first question, and that's an odd one. So the first thing I would do is make sure your calculator's in degree mode, because that's going to mess you up throughout this. And then, of course, check your answer at the back of the book. And if it's right, you can go ahead and start moving along at your own pace. And if it's not, here in about 5-6 minutes, I will go over question 5 to try to help you figure out what you may have done wrong. But it should be very similar for the questions after that too. So if there is something holding you back on number 5, we need to get it cleared up as soon as possible.
So we're trying to find this side C is.
It says solve. So you should be finding all the missing stuff. Angle A, side A, and side C. Angle A should take you about 10 seconds.
Don't start my timer for 10 seconds. said it should take 10 seconds.
Yep.
180 minus 105 minus 45.
Yep.
You
What
went
does
the
that
other
take?
edge.
That took me a few minutes.
See, I thought you were talking about the other edge. My bad.
Okay, so if you're getting stuck on question 5, or your answer's not matching up with the back of the book, then you might want to follow along with me. Otherwise, just go ahead and keep on going. Okay, so the directions here on the first couple ask you to solve. So solve implies find everything, every side, length, every angle measure that you don't already know, I guess. And so the only angle missing was angle A. So you don't have to get out law of sines or law of cosines for that. You can still just subtract from 180, and that should leave behind exactly 30. Was it not?
No.
It should be 30. So that's still the easiest way to go about that. Then, to find side A or C, you're going to have to use one of your new things. Now, technically 6.1 is law of sines, so the first few of these, until you turn the page, can be solved with law of sines. I guess if you think law of cosines will work, and for some reason you would prefer to do law of cosines, I don't really have any objection to that, but I'm going to stick with law of sines since that's what they're trying to get across. So if I'm trying to find the length of A, I have to put that with the sine of angle A, and then I can set that equal to B over the sine of angle B or C over the sine of angle C. It doesn't matter what you want. The problem is, if you pick C, There's nothing wrong with picking C, but then you're going to have an equation that has two unknowns. You don't know A and you don't know C, so you're not ever going to be able to solve that completely. That's your hint that you should be doing B over the sine of B. And then solve. And in this case, it looks like our solving is undo divided by the sine of 30 by multiplying both sides by the sine of 30. And if that's what A equals, looks like it's ready to be thrown in the calculator. Assuming you're in degree mode, and assuming you type it in correctly. Sometimes order of operations, you guys put something in the calculator differently than what you really intend to. But this one comes out to be about 14.4142. I guess technically the directions say 2 decimal places, but I'm just going to do 3 since that's what we always ask y'all to do. Okay, now that I have 2 sides, can I do Pythagorean theorem to find the third side? Is that a yes or no?
Yeah.
No. Pythagorean theorem only works on right triangles. So you need to be careful unless you want to dissect this in some way, and then you're just creating more work for yourself. So to find side C, just do law of sines again. If you want to find C, you've got to put it over the sine of his opposite angle. Okay, so now here's a question whether you got this right or not. The formula says I could set this equal to A over the sine of A or B over the sine of B, angle B. But one of those I think is just a tiny, tiny bit better than the other one. Why do you think B and sine of B is better? Alright, so one, we had to round A, which isn't necessarily a problem if we use all the decimals or we store it, and we'll probably have to do that in a question, in a further question. But the other reason is what if I accidentally did an arithmetic mistake on angle A or arithmetic mistake for side A? If I use that, then I'm for sure going to get side C wrong. So it's a little bit safer to just use B and angle B because those were given to you. But you need to solve, which is just one step. Undo divide with times. Throw it in the calculator exactly the way it's supposed to be. Gives me about 27.321 if I round to 3 decimal places. And then finally, just a good habit to get in, same thing that I bugged y'all about a lot first semester, is if you have all 3 sides and all 3 angles, you might as well spend 5 more seconds to make sure your smallest side is opposite smallest angle and biggest side is opposite biggest angle. Because if those 2 things are not true, then you should know that something went wrong. Doesn't guarantee that your answer is right, but it would guarantee that your answer is wrong. Okay, anything specific about 5 while it's up? Okay, I will leave it up there, but if you do see something specific, then please ask. Otherwise, go ahead and keep going. Once I think everyone's had time to get to and try 11, I will also go over 11 just because my other 2 classes today asked about that one, so I assume y'all will too. You remembered how to do the 20 minutes?
Like the one thing I remember from last year. It just felt weird not looking at a triangle with it. Just looking at it. Threw me off.
that you've had some time to try a few. Questions 8 or 11, 37 and 39 are both one of the new area formulas. Any of those that you'd like me to go over?
I just don't remember how to get through that.
You're gonna need to wait for the pass to get back. If he's not back in a minute, I can give you the backup. But he should be here soon. Yeah.
It's like the minutes and seconds thing or whatever, degrees.
Oh, yeah, so that's what's holding you back on that one?
Yeah, I think I remember like how you convert it to number.
A minute is a 60th of a degree. So it's got 20 minutes. This is the same thing as 83 1/3 degrees, or 83.3 repeating degrees. Like that. Okay, I don't know if many people have gotten far past that, but 45 is a very good question, but you only need to find one side length. But I like that one because it's a little bit more realistic than a tree that's straight up and down like you normally see. Does anyone know that they need help on 45 yet?
Just got it.
Okay.
I might actually be done before the class is over. That'd be crazy.
Keep going. Okay. I suspect someone will ask about 47, but I don't think enough people have tried it yet, so I'm going to wait just a little bit longer on that.
Every floor in both phases, only one bathroom did not smell like weed or wasn't occupied.
It's horrible.
There's trees. There's trees. Outside.
Yeah. What did he do? Or are we just not?
Okay, I'm going to look at question 47. So if you think it would benefit you, then please follow along here. But it has a similar trick that I think you also need in 48. Something we used last semester, but it has been a while. All right, for question 47, we've got a couple fire stations, which sounds like some questions from last semester. We've got the distance between the fire stations, and they have a couple angles worked out for us already. So this bearing is 65 degrees to that one and 80 to this one, which means this must be 15. So, oops. 15, try to make it look like that. And then there's another bearing over here where they give us that this is 70, and from this we were supposed to be able to figure out the distance from this station to the fire and this station to the fire. So basically find two sides of your triangles. Now, kind of the problem with this one is, and one thing I really like about law of sines and law of cosines, is if you're not sure if you have enough information, you can just start it and try. So if I'm trying to solve for x with law of sines, I've got to pair it up with the sine of its opposite angle. And although they didn't tell me this angle was 15, you know, if this whole thing is 80 and this is 65, it's pretty quick to figure out that that's 15. And then I know that I have to set it equal to a length that I know divided by the sine of its opposite angle. Now, I don't know this length. That's another part of the problem, but I do know this length, so I'm going to put 30 over the sine of his opposite angle, which would be over here. And that creates a little bit of a problem. I don't know this, and I don't know this, so I can't solve this equation yet. I've got to figure out what this angle is, and then law of sines will work out nice and neat. But looking in this mess, this 15 degrees is pretty much the only easy angle to find. And I need more angle information. So one of the things, little tricks we had to do last semester, and this comes up quite a bit with bearings, but if this was a north line and this is a north line, that guarantees that they are parallel. And the nice thing about parallel lines is if you have a line intersect them, which we call a transversal, then you have all those angle relationships. So I look at this one and see it's in the top left, so it's going to alternate with the bottom right, and they're in the interior of the two parallel lines. So if this is 65, that is 65. And then if I know this whole angle is 135, and I know this is 15, I could subtract these two from 180. And then you get that this angle that the fire makes with the two stations is 30 degrees. So again, kind of the nice thing about these formulas is you just start using them, and then if you don't have enough information, it's pretty obvious what you need to go and find. Doesn't mean that it's easy to find, but at least you know what you need to be doing. So then it looks like this distance, what I labeled as x, is going to be 30 sine of 15 over the sine of 30. And that is ready to be thrown in the calculator. About 15.529 kilometers. Okay, and then the majority of the legwork is done, but it also wanted to know this length, so I called it y. So y needs to be put over the sine of his opposite angle, but I've already had to figure that out for the first part, so that's ready to go. And then you need to set it equal to a different length divided by the sine of his opposite angle. So I'll just reuse the 30 and the sine of 30. And so it looks like y is going to be 30 sine of 135 over the sine of 30. And as long as we are careful about how we put that in so that our calculator does the order of operations correctly, we shouldn't have to guess if that makes sense or not. But of course, my recommendation is to also put these links on your picture. And of course, make sure that the biggest length of that triangle is opposite the biggest angle and smallest length is opposite the smallest angle. If those two things are not true, then you know you have a mistake somewhere. But the one thing that's a little bit different about that question is the part that I have highlighted. You need more angle information, so use these parallel lines. You don't have to use alternate interior, but you need to use one of those angle relationships. I just used, if this was 65, this would have to be 65. And again, I think you have to do something pretty similar on question 48, if I remember right. Okay, so finish getting what you need out of that, and then hopefully you can move on to the other page here in a moment. Practice a couple law of cosines, a couple Heron's formula, and be close to finished with this. You guys still have about 10 minutes of class, so you could get a couple more done. But if you do not finish, then please make sure that you try the rest of those between now and Friday. Friday we'll have two big objectives. One is for me to answer your book questions that can work out for you. So you're not going to know what to ask if you haven't tried them all. So that's why you need to do that on time. And I will have a worksheet / practice quiz that has law of sines, law of cosine stuff mixed up. And it'll give you an idea if you're really prepared for the quiz or if you need to study some. So that'll be our plan on Friday. We'll do that quiz on Monday. It'll be like a 20-30 point quiz. So won't impact your grade too much by the end of the semester, but of course, being the first major grade of the semester, it will make or break your grade temporarily. So, yes.
Is this, are we gonna turn this in for a grade?
Don't you normally turn things in for a grade?
But I was just, never mind.
Yes, I will take it up for a grade. Yes, you should get a few homework points for this, a few homework points for the worksheet that I give you on Friday, and then you'll get some major points from the quiz on Monday. I try to give you plenty of great opportunities. about 5 minutes away from dismissal here. So again, please make sure that you try the rest of those questions. So if you need some help, you will know which questions you need to ask about at the start of class on Friday.